In this video, we're looking at the bitwise functions in the game. As usual, I need to emphasize that this is a video game and not real cybersecurity. So, bitwise, what is it and how can we use it? Bitwise is a series of different functions that can be used to manipulate binary numbers and have them interact with each other. So, we should just start by showing off the, I have a bitwise command that we can use to show some of this. We have bitwise, and then we're just going to take two numbers, 12 and 10. And here you can see the different bitwise operators. So you have the AND, you have the OR, you have the XOR, you have the left shift and the right shift. And what happens is that these numbers, the 12 and the 10, are converted into binary numbers, and then they are combined according to one of these rules, depending on which one we chose. So let's, for example, say that we take the AND function. The 12 is converted to binary, which is 1, 1, 0, 0, and the 10 is converted to binary, which is 1, 0, 1, 0. And the output is the number 8. So according to the AND rule, if you combine these two binary numbers, you get the output 8. So what does the AND rule look like? Let's just write these numbers down. So this is going to be 8 somehow. And the AND rule says that if both numbers, so you can imagine that you're like adding these together, kind of. You take the top number and the bottom number directly below it, and you combine them according to some rule. And the rule for AND is that if both numbers are 1, then the output is 1. Otherwise, it's 0. So you can see here 1, 1, that is 1. 1, 0, that is 0. 0, 1, that is 0. And then 0, 0, that's also 0. So the output in binary form is 1, 0, 0, 0. And if we just let's see here, I'm going to take the binary number and convert it to a normal number just to see what it says. If you convert the number 1, 0, 0, 0 into a normal number, you get the number 8. So this is how the AND function works. Let's take the OR function. So there is when you use OR, there's another rule. And here the rule is that, let's remove the output. Here the rule is that if one of the numbers is 1, it doesn't matter what the other number is, it could be 0 or 1, then you're going to get the output 1. So for 1, 1, you get the output 1. For 1, 0, you get the output 1. For 0, 1, you get the output 1. And for 0, 0, you get the output 0. So let's see what kind of output that's going to give us. Let's do the OR function. And that gives us the output 14. And if you want to check if that's correct, and just do the output, convert it into a normal number, and it also gives us the number 14. So that's what happens when you use the OR function. Then you have the XOR function, and in the XOR function the rule is, let's see here, that if one of the numbers is 1 and the other number is 0, then you get a 1, otherwise you get a 0. So if both numbers are 1, then you get a 0. But if one of the numbers and the other number is 0, so here 1, 0, you get a 1, and the same in this case, 0, 1, also 1, and then 0, 0 is a 0. So we can test this as well. let's see here. So XOR, yes. That should give us the number 6. And if we want to check that, we can use this number right here. And the number is 6. Okay, so those are the 3 logic arguments. And then you can also shift the binary numbers to the left or to the right. So let's do that. Let's start by shifting it to the left. So what it does is it takes the number 1100 and then it shifted a certain number of spaces to the left. Let's just show what that looks like. This is kind of the rule here. So for this, we have this number, and we want to shift the, let's say that there's a comma here, and then there are a bunch of zeros, just to make this easier to understand. And then what you do is you are going to move this comma a certain number of spaces to the right, so in this direction, and the number of spaces is this number in a normal number form. So this is actually the number 10. We're going to shift it 10 spaces. So let's see here. We're going to go 1, 2. Well, let's just do a bunch of zeros first, like this. We're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. And we're going to take this number. We're going to once again, well, let's do this. Do it like this. Hopefully I did the correct amount of zeros. And as you can see, this number, binary, big binary number, is the number 12,288, which is the output we got here. So what you just did was you shifted the numbers 10 space, or the comma 10 spaces to the right, which means that the number in and of itself was moved, or this binary number right here was moved to the left. Okay, and when it comes to the right shift, you do the exact same thing but the other way around. So if we let's see here, let's just take this one, we're going to right shift it, and then we get the number 0. So we can again make this example. The amount of spaces we want to move the, let's do this again. So this is the number we have, and then we want to shift it 10 spaces, but this time we imagine the comma here, we want to move it this way. So if we add a bunch of zeros in front of the number, and then we start moving it, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put the comma here. That means that the number is now 0, because there is, well, the number is 0.000. But these zeros, just like we added a bunch of zeros in here, everything on this side, so these zeros just magically appeared. And if you shift on the other way, the zeros just vanishes. So all the stuff that is to the right of the comma is just removed, and that means that all we have left is a 0, which is what we can see here. So those are the bitwise functions and how they work. So they are essentially ways we can manipulate the normal numbers by first turning them into binary numbers and then moving them around in some way. And the most common way you're going to be using these, or at least probably in the game, is when it comes to encryption. And what we're doing in encryption is we're trying to convert the values we have into something unreadable and then convert it back again. That is the basic idea of encryption. So if you take a look at some of these, well, I'm probably going to have to explain that, but some of these bitwise functions are not reversible. So the information that is manipulated is, or part of it is lost. So for example, this is a great example. We just shifted all the numbers. It doesn't matter what it said here. Could have been any number of zeros and ones. If we shift it so that there are nothing left, that this is just removed, deleted. We have no way of knowing what kind of numbers were here before. But there is one bitwise function that can be reversed again, and that is the XOR function. Let's just go down a bit again here and take the bitwise function, which was this one. So if we combine this one with this one according to the bitwise rule, we got this. And what we can do is we can reverse this. So if we take the output, the result, this one, and combine it with this one, the output is going to be this one. Let's just do a equal to sign. And likewise, if we take this value, the output, and this value, the other value, I'm going to explain this more in detail. Then you get this value right here. So let's go over this. According to the rule, we have 0, 0. Well, let's start from this side. We have 0, 1, which means that's a 1. We have 1, 1, which is a 0. We have 1, 0, which is a 1. And we have 0, 0, which is a 0. You can see this is the output, which was expected. So when we use the XOR on the output and one of the inputs, we get the other input. And we can also do the same for this one. 0, 1, that's a 1. 1, 0, that's a 1. 1, 1, that's a 0. And 0, 0 is a 0. So again, regardless of which way you use this, you will always get the other. You will be able to reverse the XOR again and get all the information back. So no information is lost here. And in all the other cases, information is lost and we cannot retrieve it again. But in the XOR case, it's not lost. So what we can do is we can scramble a message or a number or whatever to such a degree that it's well, with the current processing speed, impossible to reverse it again. This way we can first encrypt the message and then decrypt it again, and nobody can understand the garbled mess that the encryption made, but it's then reversible again. So this is why the XOR is so important in encryption. Well, the XOR at least. Well, yeah, bitwise. So let's take some examples of this. Let's start scripting something with a bitwise. Let's see, bitwise. And as well as usual, we get the information on how you can create the bitwise functions up here. So you're going to take the operator, which is the symbol that is associated with the function. and we're going to be using the XOR symbol. And then we're just going to show this example that we just did again. So we have the integer. What you can do is you can use let's use the normal values instead here. So we have 12, we have 10, and then the output of 12 and 10, when you bitwise them, was the number 6. So we can do 6 and 10, and we expect that to be 12. Let's see here, let's just do try to make this as clear as possible. 6 and then what are we missing here? 12 and 6, right? 12, 6, and it doesn't matter which order you put them, if it's the first one or the second one, because according to the rule it just combines according to if it's a 1 or a 0, and it doesn't matter if it's the top row or the bottom row, as you saw when we did the calculations. Let's see here, this is 10. So what we expect is that the 12 bitwise with the 10 is outputting the 6. Then if you take the 6 and the 10, you get 12, which was this number right here. And if you take the 12 and the 6, you get 10. And let's just print this. And see if it works. And as you can see, the first number is 6, second number is 12, and the third number is 10. So no information is lost. You can convert the numbers according to the XOR without losing any of the information in the numbers. And how does this then relate to the encryption? What you can do is you can convert letters, for example a password, into numbers, and then you can scramble it according to some bitwise rules, mainly XOR. And then if you know the output result, so you can see here 12 and 10 gives us the number 6. Then if we know the one of the numbers and the output value, so if we know the number 10 and the number 6, then we can get the number 12 back. The number 12 is not lost. Let's just create a very short example of this. We have a password. Just make a variable called password, or let's make it shorter, just pass. And the password is of course password 123. And then what we do is we're going to take all of these letters and numbers and convert them into numbers. So we're just looping the password. We're taking all the characters and looping them in a for loop like this, and then we're going to just to start off, let's hide these for now. We're going to print the let's actually do this, print the character and then the character code. You can convert the different characters into numbers by taking the ASCII code or getting the ASCII code. Start again. So you can see here the character P has the number 112, A 97, and so on. We have all these numbers. And then what we can do is we can okay, so we're going to have a secret number that is the bitwise, or the bitwise XOR, and the hidden value that nobody else knows, at least in this example. We have the secret, and the secret number is the number, let's do 42. Number 42 is the secret number. And so what it's going to do now, or we're going to make it take these code numbers and it's going to XOR those with the secret number. So we'll take the bitwise function and we're going to XOR the key.code, which was the character code for the different characters in the password, and we're going to bitwise that with the secret number. And then we are going to save that in a, let's see here, how will we want to save this? I think we're going to save it into list. We just make a list. So we just push that in here, and I think this is fine. Yeah, this is fine. So let's remove the print and see what happens to the password when you put it through this scrambling. Let's just print the list. Like so. And what we got now are different numbers. So before we had 112, which was the P, and 97 was the A, but now the P is represented by the number 90, and the A is 75, and so on. So the numbers are quite different. And if somebody just saw these numbers, it would be, well, depending on how good they are, it might be hard for them to figure out what the initial character was, and what they would need in order to figure this out is the secret password, which is the number 42. I should maybe clarify that this, what I'm showing now, is the very, very basic. So somebody who knows some cryptography would easily be able to crack this kind of encryption. Okay, so then what happens is we can take the list and we can reverse this information if we have the secret password. So we take the list, and we're just going to loop again. And this time first we loop the characters, and now we're going to loop the numbers from the list, and then we're going to use the bitwise again. And we're going to take the numbers, which is L, and then we're just going to bitwise it, XOR it with the secret password right here. And again, we're just going to, let's do here, output. The bitwise like this, and then just going to print the output. So what this is going to do is it's going to loop again the numbers in the list and reverse the first scrambling by again bitwising with the secret password on the output. On the output from this for loop to create or reverse the password again. And as you can see, the numbers we got now are the numbers from the first one. So we got the 112, we got the 97, the 115, so P, A, S, S, and so on. So it was able to reverse the password. And then what you might want to do is, instead of printing out the numbers, we want to also reverse this part, which was the code where we turn the character into a number. And the way we do that is with the character function. So it works like this: character, and you put a number inside it, and then it spits out the character. We're just going to take the bitwise result, put that inside the character instead, and run this. And now you can see that the information is P, A, S, S, W, O, R, D, and so on. We was able to reverse it again. And what you can imagine is that if you were to use a bunch of different secret information, secret codes, as well as a lot of scrambling with these bitwise functions, it would be very hard for someone to reverse engineer your scrambling and also figure out what the password you must have used in order to create the scrambling. So this is the principle on which the encryption is based, and this is also the main use in the game with which you can create protection for your servers. Okay, so this is an introduction, or this was an introduction to the bitwise functions, mainly the XOR. I hope it made some things clearer, at least for someone who is completely new to this stuff. Yeah, you can like the video if you liked it, leave a comment, and you can also join the Discord that I have a link to in the description. And I'll see you guys in the next one.